All right, let's go ahead and take a look at another graph here. Now we're going to draw a graph and state the domain and range for each function. And now we're going to do f of x equals x to the 4th power. So let's go ahead and grab our calculators again. And we're going to go back into our y equals screen. Now that we'll still have x to the 3rd power in here, so we'll just go ahead and change it to a 4 instead of a 3. And then we go to our graph, and now see that it again looks like a parabola here. So now we're back to a shape that we're a little more familiar with here. I'm going to keep our scale at 0.2, which is what it should already be set at. So when you go to your table, you should see that it's again counting by 0.2s. So let's go ahead and start plotting our points here. That should be a little easier this time. So I've already set up my scale. We're counting by 0.2s again, so make sure yours is the same. And let's go ahead and use our red pen here. And sorry, we got to get our calculator back here. All right, so let's plot the point. Let's start at 0, 0 again. I like to start in the positives. So 0, 0 it is, and we'll plot our point right here. And then we have the next point is 0.2, and then 0.0016, which is again just going to be slightly above your 0 mark here. And then we have 0.4 at 0.02, excuse me, so 0.4 at 0.02, so again just a little bit above here. And then 0.6 at 0.12, so 0.2 is right here, so it'll about be halfway in between. So there's that. And then 0.8 at 0.4, so 0.8, 0.2, 0.4 is going to be right here. And then 1, 1. Perfect. 1, 1 again. Seems to be showing up quite a bit here. Now let's go down a little bit more, see if the next one shows up. 0.2 and 2, that's not going to work. So let's go back into the negatives here. And now if you see here, negative 0.2 gives us positive 0.0016. So we're going to still be above the x-axis here with the point right here. Negative 0.4 and 0.0256, so just a little bit higher. So right about there. And then negative 0.6 and then 0.1, so we're right here. Notice we're exactly symmetric to the y-axis, so we actually know our next point is going to be right here at negative 0.8 and then 0.4 and then negative 1, 1. It's going to match up with exactly on the other side. So we do have a U-shaped parabola here, and I'm going to go ahead and try and connect as best as I can. And again, putting arrows on the top because we know it's going to keep going up. And there we go. There's our graph. Alrighty, we're done with this guy. So now we've drawn our graph, so check there, and we need to state the domain and the range for the function. So now let's go ahead and do our domain and our range here. So domain, remember domain is our x values, so all we really care about is the x-axis right now. So if we squished our graph down to the x-axis, both sides would flip down, and we'd have one continuous line going the whole way, so our domain here is going to be negative infinity to infinity. Oops. There we go. And then for our range now, our range is going to be, now be careful here, so when we squish that up to the y-axis to find our range, we know that this left part of our parabola here is going to go squished up, and then this right side is going to get squished up as well. So you just imagine both sides caving in. Now, since both of these are pointing upwards, we have nothing pointing downward. So remember, to find our domain of range, we always start in the negative direction. So what's the first thing we hit when we're coming up the negatives here? Well, the first thing we hit is right here, which is the point 0, 0. So we actually start our range at 0. And now remember, we want to include that point because we actually have a value there. So that means instead of a parenthesis, we need to use a brace, such as this. So we have a brace with a 0 on it, meaning we're going to use that value of 0. And then we're going to keep going up into this direction. Now here, since we have arrows, we're never going to stop. So up in the positive direction, we go to infinity. And remember, with infinity, we always just use a parenthesis. So there's our range for that one. Alright, as you notice, we have a couple properties that we need to just talk about here. So for number one, the graph of every nth power function of f of x is x to the nth. So this n here is going to change, either be 1, 2, 3, 4, 5, 6, 7, etc., etc. It's going to pass through every point we saw was on the origin. They all pass through the origin right here. So that means we're going to have that point 0, 0 for every single graph that we have. So So because 0 to the nth power, so 0 to the first, 0 squared, 0 cubed, 0 to the fourth power, 0 to the fifth power, all we're doing is multiplying by 0. And we know anything multiplied by 0 is going to give you 0. So you have 0, 0 for any value. So it's always going to go through the origin for whatever number you have for n. Number 2, we can break them down into evens and odds. So like even would be x squared or x to the fourth power. Odds would be x to the third and x to the fifth power and seventh and ninth, etc., etc. So if n is even, notice these look very, very similar. The even power functions have a reflection symmetry, meaning the graphs are symmetric to the y-axis, which means you can fold them over on top of each other. That's what reflection symmetry means, like looking in a mirror. Each side is exactly the same. So they're going to be symmetric to the y-axis and kind of have a parabolic shape. So they're going to make parabolas. Now if n is odd, those are these graphs over here, not symmetric to the y-axis. Notice if we folded along the y-axis, this would not land right on top of this guy, but they have rotation symmetry, which means if we take everything in the first quadrant and rotate it 180 degrees, it would land exactly over here in the third quadrant, exactly rotated around. Like you could spin this and it would land on top of each other. So picture like a twister spinner. Right, so that means that they're going to have rotation symmetry, and they're all going to make sort of like an S curve, okay? So those are your properties that you can remember here. All right, last question, multiple choice. Which is the graph of the function with the equation f of x is or equals x to the 7th? Justify your answer. Alrighty, so we know they all have to go through 0, 0. We just talked about that, so this guy does, so we're good there. This one also goes through 0, 0. So does this one as well. Now the other distinguishing feature we had was that it's an odd number. So you got to think to yourself, is that going to make an S curve or is that going to make a parabola? If you remember, your odd numbers are going to make S curves. So this guy is a keeper so far. This guy's a parabola. That's not going to work for us. We don't want a parabola. That would be if it was x to the 8th or some even number. This guy doesn't even make a parabola or an S curve, to be frank with you. It just makes one curve. So this is probably not even a power function if I had to guess. So that's not going to work either for us. So our choice here we want is going to be A, because it makes our S curve, goes through a 0, 0, and that is the properties of f of x equals x to the 7th.